Hey everybody, my name is Calvin and welcome back to my channel. Today we're going to be going over the two pointers technique. Two pointers is a problem-solving pattern where you use two indexes to move through a list or a string in a controlled way instead of opting to use nested loops. The reason it's so useful is that a lot of problems come down to finding or validating pairs, comparing elements from both ends, or scanning efficiently while maintaining some condition. With two pointers, you can often do that in one pass, which takes you down from O of n squared down to O of n. In practice, you'll see two pointers used in a few common ways. One is on sorted arrays, where you put one pointer on the left and one on the right and move them inward based on whether your current sum is too small or too big. Another is comparing from both ends, like checking if a string is a palindrome, where you move the pointers inward while skipping characters you don't care about. You can also see a lot of read and write version where one pointer scans and the other builds an in-place result, like removing duplicates from a sorted array. The core idea across all of these is the same. Every pointer move should be justified by the structure of the problem, so you know that you're not skipping the correct answer. To demonstrate the two pointers technique in action, I'll be solving 4 LeetCode questions that you can feasibly see on a coding interview. It's a great technique to know if you're trying to get into LeetCode. If you'd like to follow along with this video, the code is linked in the GitHub repository down in the description. Our first problem is 2 sum 2, which is the sorted version of the 2 sum problem. The problem gives us a sorted array called numbers and a target, and we need to return the one index position of 2 numbers that add up to a target. If we did this naively, we might try every pair, and that would be O of n squared. But because it's sorted, we can do something smarter. We can put one pointer on the left and one on the right. And if the sum is too small, we can move left to increase it. And if the sum is too big, we can move right to decrease it. We have a couple tests that we will be testing our function on and the expected outputs. So for this example right here, given a target of 9 and a numbers list, we want to see the one index position that adds up to target. So in this case, that would be 2 and 7, index 1, index 2, which equals 9. Same thing right here, 2 and 4 equals 6, and -1 and 0 equals -1. The first thing that we're going to be doing is creating a left variable, and we set that to 0. This will be our left index, or left pointer, and then we have a right variable that starts at the length of numbers, -1. These will serve as our 2 pointers. While the 2 pointers don't interlap, we want to find the current sum at the 2 pointers. If we hit the target, we want to return the one index positions. If our sum is too small, we want to move our left pointer to the right to increase. If the sum is too big, we can decrement the right pointer to decrease it. This is the 2 pointers technique implemented for the 2 sum 2 problem. And we can test it out. Should expect to see 1, 2, 1, 3, and 1, 2. And we see that that's exactly what we get. Our next problem is valid palindrome. This is a very common problem that you might find in LeetCode. We're given a string, and we need to check if it's a palindrome while ignoring any punctuation, spaces, and casing. Two pointers is a great technique to use here because palindrome means the ends match. We move inward, skipping anything that isn't alphanumeric, and compare lowercase characters. The thought process here for our solution will be having 2 pointers from both ends, skip any punctuation and spaces, and then we compare the lowercase characters. Let's get started. First, we'll initiate our pointers as usual. Our left pointer will start at index 0, and our right pointer will start at len of s minus 1. Well, while moving inward, we want to compare left and right pointer. We want to skip non-alphanumeric on the left. Skip the alphanumeric on the right as well. And then we want to compare the lowercase characters. And if they don't match, we know that it is not a valid palindrome. And then we increment and decrement our left and right pointers. And if we make it to the end of the loop, we know that it is a valid palindrome. Again, we have 4 test cases here: a man, a plan, a canal, Panama. This is a palindrome, a valid palindrome, even though there's a colon right here, or commas, because we're just skipping those. Race a car is false. Space should return true, because a 1 blank character is a valid palindrome. And then 0p is false. There we go. A little bit of a bug there, but now that we've fixed it, we can see that our function is working correctly. True, false, true, false. Our third problem here is called container with most water. The naive approach here is again O of n squared, where we try all pairs. The 2 pointers idea here starts with the widest container, then we move inward. The key reasoning here is that the area is limited by the shorter side, so the only pointer move that can possibly help is moving the pointer at the shorter height. We want to start with widest container, or the ends. Then the limiting factor here is the shorter height. Moving the taller side can't increase the limiting height, so we always move the pointer at the shortest height inward. Let's again start by initiating our left and right pointers, the same way we've done before. This time we'll also have a best variable right here. The limiting height is the smaller of the two sides, so we can take the min of height index left and height index right. And the width is distance between the pointers. And then we want to update our best variable to the best area. And then we want to move the shorter side inward. Only moving that can improve h. Else we can decrement by 1. Once we're done with the loop, we can return the best result. And that's our implementation. Again, for this problem, we have a few test cases. One, where we have this list of numbers, 186254837. The best container here is made by the line with height 8 at index 1, and the line with height 7 at index 8. The width is equal to 8 minus 1, or 7. Height is equal to the minimum of 8 and 7, which is 7. And then the area is 7 times 7, which is 49. For our second test case here, we have 1 and 1. There are only two lines, which is at index 0 and index 1, 1 and 1 respectively. Our width here is equal to 1 minus 0, which is 1. And then our height is equal to the minimum of 1 and 1, which is trivially 1. And then area is just simply 1 times 1 equals 1. We can test our function right here, and we can see that our two pointers technique works in this case as well. The last problem that we're going to be approaching is called remove duplicates from sorted array. This is the read and write pointer style. Because the array is sorted, the duplicates are already grouped. We scan with a read pointer, and we build the unique prefix using a write pointer. Whenever we see a new value, we can copy that into the right position and then move the right index forward. Here, we're going to be starting a little bit differently. If we want to start with the case that if we have an empty array, which means that there are 0 unique, this will check for a empty array. And then we want to create our write pointer. Our write pointer here will contain the next unique value. That should go there. We're going to start with at 1. And then we want to scan through the array using a variable called read, our read pointer. In the scan, if current differs from the previous, then it's a new unique value. If that's the case, then we want to set nums at the write pointer equal to the nums at the read pointer. And increment write by 1. Once we're done through that loop, we want to return write, which is the count of the unique values. And that's our implementation for remove duplicates from a sorted array. We have two cases that we're going to be testing this on. K should be equal to 2 in this case, and nums from K. Again, we have two test cases right here. this test case with a nums array of 1, 1, and 2, and k, which is the remove duplicates of nums, we should get 2 unique items from the array, and we'll get 1 and 2, because 1 here is obviously the duplicate. Same thing right here. We'll have 5 unique values, 1, 2, 3, 4, and 5. And this is our sorted array. And we can see that that's exactly how that works. And that's that for the video. If you coded along with me, or even just watched along, you now have a solid feel for how 2 pointers actually works and how to decide which pointer to move and why. If you want to keep practicing after this, pick one new 2 pointers problem and try to narrate your pointer moves out loud the same way we did here, because that's what kind of makes it stick. Again, the code is in the description, and thanks for watching. Don't forget to comment, like, and subscribe if you'd like to see more content like this.